Hi, today we are going to talk about how to graph exponential functions. That's just a basic overview. So we have a general form f of x equals b to the power x. We do want to recall that exponential functions b has to be greater than 0. We do not use negative values here. And we normally also say that b cannot be 1, otherwise you are not getting an exponential function. So x itself, the variable, can be any real number. So the domain of an exponential function can be written these two different ways. We're going to take a look at graphing f of x equals 2 to the x. So we're going to use a table of values and pick these x values to work with. And so what we do is we're going to take these exponents and put them there. So when you raise 2 to the power negative 3, that's going to give you 1/8. When you raise 2 to the power negative 2, that's going to give you 1/4. Negative 1 will give you 1/2. 0, anything to the power 0 is 1, so you're going to get 1 here. 2 to the power 1 is 2, 2 to the second power is 4, and 2 to the third power is 8. This is what we got so far. So let's plot these points. Positive 3 will have 8. Positive 2 will have 4. And then 2, just 1, 2, 0, 1. Then we get half, a quarter, and an 8. So you're going to see these points are going to start to approach the x-axis. We are going to connect them. These points are relatively easy. Here it gets a little tight, but one thing to keep in mind that this graph is going to follow along when you go to the left now. It's going to follow along the x-axis, but it will never cross it. So it's going to just get closer and closer and closer. The domain, as we already know, is from negative infinity to infinity, all real numbers. Range, so this stays entirely above the x-axis, but it's going to get very, very close when we go this way. So the range is going to be from 0 to infinity. The x-intercept, it does not cross the x-intercept, so we don't have one. The y-intercept is right there, it's 0.01. And a couple other things. So as x goes to infinity, so we go to the right, what's happening with the value of y? Well, the value of y goes up to positive infinity. And as x goes to negative infinity, that's heading that way. The value of y is going to be getting closer and closer to 0. That's this graph. Our next example. 3 to the power x. So we're going to do exactly the same process. We have a table of values, same numbers I used before. So let's start here. 3 to the third is 27. 3 squared is 9. 3 to the first is 3. 3 to the power 0 is 1. And here we're going to start getting reciprocals. 3 to the negative first is 1/3. 3 to the negative second is 1/9. And 1/27. So at this point we do not have enough space here to plot that. This point does exist, it's a valid point, but we just don't have enough room because this only goes up to 10. But 2, 9, 1, 3, 0, 1, 1/3, 1/9, 1/27. This is going to start getting very difficult to get these fractions here accurately, so we just do our best. But we should observe that our graph is going to be very much the same, except it's going to be steeper than the previous one because we have a base that's greater than the base 2. Base 3 is greater than 2, so the graph is going to rise faster, but the overall behavior is going to stay the same. So the domain is going to be all real numbers. The range is still going to be 0 to infinity. The y-intercept is actually 0, 1 still. The horizontal asymptote is going to be y equals 0. By the way, my apologies. I forgot to do it in the previous problem. It is also y equals 0. Horizontal asymptote is this line to which the graph is going to approach infinitely close. Okay, and same thing happens here. As x approaches infinity, f of x approaches infinity, and as x approaches negative infinity, this is going to approach 0, which is our horizontal asymptote. I have one more example. F of x equals 1/2 to the power x. So here, let's start with positive exponents. So when you do 3, it's 1/2 to the third power, which is 1/2 times 1/2 times 1/2, that's 1/8. 2 will give you 1/4. 1 will give you 1/2. 0 will give you 1. -1. So now you start reciprocating. So when you do 1/2 to the power of -1, it is actually 2 to the first power, which is 2. And this will give you 4, and this will give you 8. So if you actually compare it to the table for the first example, you will see that the numbers kind of flipped. Let's plot that. -3, 8, -2, 4, -1, 2, 0, 1. So 1/2, a 1/4, and an 1/8. You can kind of see how this graph is going to look like a reflection of the first one we did. So now it's going down. The domain is still the same, all real numbers. The range is still going to be 0 to infinity. The y-intercept is still going to be 0, 1. The horizontal asymptote is still going to be y equals 0, it's still the x-axis. But for the other two things, so as x goes to infinity, this side here is actually going to approach 0. And when x goes to negative infinity, this end goes up to infinity. So, like I said, things kind of flip. Okay, so that's the basic, all the basic of graphing exponential functions, and I hope this helps.